Hi, some of you struggle with question 8 of empirical formulas, so I'm just going to do a little worked example for you here. So in the first part of the question, it is the normal empirical formula calculation. And the new thing, I guess, for some of you is this term relative molecular formula. And I'm not sure I like that term. Yeah, it's the MR, or the relative molecular mass, right, which would be 60 grams for 1 mole. Okay, so perhaps the ones that were struggling with that term, relative molecular formula. In any case, let's work through it. It looks like we've got a compound with carbon, hydrogen, and oxygen. So in the usual way, we're going to draw our little table with carbon, hydrogen, and oxygen, like so, and we're going to put the masses under each. Right, so we've got 40.0 grams of carbon, we've got 6.7 grams of hydrogen, and we've got 53.5 grams of oxygen. But as usual in chemistry, we want moles, not grams, so we're going to divide by our ARs, which is 12 for carbon, which is 1, and 16 for hydrogen and oxygen. Okay, so those numbers turn out to be, sorry, just to be double clear, with the formula I'm using is moles equals mass over, in this case, AR. So that's what I'm using there to find the moles. And so now we want to work out these numbers. They turn out to be 3.33. This is itself. And this one is 3.34. Okay, so now we want to turn these numbers into whole integers. So we pick the smallest one, which is this one, and we divide it by itself. So that's going to turn it into 1. But we have to keep the ratio the same, so we have to do the same to each. So I'm going to divide this one by 3.33 as well, and this one 3.33 as well. So within experimental error, this comes out at 1, 2, and 1. So the empirical formula, I'll shorten it to EF for empirical formula. The empirical formula is carbon 1, hydrogen 2, oxygen 1. All right, so that's the empirical formula. And the relative empirical mass, so the relative empirical mass of this formula is just the 12 for the carbon, right, the 2 for the 2 hydrogens, and the 16 for the oxygen. Which comes out to be 30. Okay, so now what we do, and this might be the new part, so we want to find we've already found the empirical formula, but we want to find out the molecular formula from the empirical formula and this MR. Okay, so what you need to do is divide the relative molecular mass, so the relative molecular mass, which is the MR, divided by the relative empirical mass to find out how many empirical units go into the molecular formula. Okay, so that is 60 from the question, and we've just worked out the relative empirical mass is 30, which is 2. Okay, so we've got 2 empirical formulas within the molecular formula. All right, so the molecular formula becomes C2H4O2 QED.